So this is a case study of rewriting an open source, my open source music project from Java into Scala. And it was actually sort of an accidental experience in that I had taken Dick Wall of Java Posse fame's Stairway to Scala class and thought, okay, what next? I need to do something. I decided to rewrite my own project into Scala, and I got a 10-to-1 reduction in lines of code. And I'm like, okay, now it got my attention, because this is sort of my first real Scala project, so I'm not even any kind of expert in the language. And so I thought, let me dig in and see what happened. How did I get a 10-to-1 reduction in lines of code? And almost more interesting, when I didn't really set out to do this, but when I looked at the code that I had written, there was only one mutatable variable. Everything else was what we'd call final in Java. And I would not have predicted that that was possible, but I did it without even sort of meaning to. So I'm hoping to give you, if you're new to Scala or thinking about doing Scala, I'm 15 feet ahead of you, but I've seen 15 more feet. So we'll take a look at that. The obligatory background. I relatively recently changed jobs from Motorola Mobility, where I did video on demand for a bunch of years, to a small company called Cabot Research that does financials. So some of the material says Motorola, some says Cabot, but I'm out of the big company down to the little company. And I do a bunch of writing. And like I said, I think of myself as a Scala advanced beginner, and got experience with a bunch of languages. So, been around the block with languages, but still pretty new to Scala. So what we're going to do here is we're going to basically say, what are some of the reasons that we did the rewrite. I'm going to give you some background about the system that was the target of the rewrite. I'm going to give you some description about it. I'm going to give you the world's smallest primer on Scala. And then we're going to walk through the code. Basically, the gist of it is we're going to go back and forth between Java in Eclipse and Scala in IntelliJ, and we're going to see what the differences are and similarities. And then we're going to go, do conclusions, takeaways, and stuff. So, hopefully, anybody know what this acronym stands for? Okay, it's learn a new language every year. It was coined by Dave Thomas, one of the pragmatic programmers. And he basically said that every year, try learning a new language. Not that you would actually start using it in production, and not that you would actually even go to the point of becoming proficient in it, but you'd get yourself exposed to it. And so you would just learn some new things. There's a lot of languages out there. They all take different takes. They have different takes in the problem space. And sometimes just by being exposed to one, you can bring the concepts over. The second point here sounds a little weird. Why is functional programming like NoSQL? At a certain level, they're not at all similar. But functional programming is one of the backgrounds of Scala. And if you've done any job hunting, like I did recently, functional programming and NoSQL are the buzzwords that you're required to have on your resume. And you're required to say that you've been doing these things for 10 years, even though they may not have been around for 10 years. I'm looking for someone with 4 years of iOS 6 experience. These are good things just to even be able to be aware of. And the other thing is that thinking differently does make you smarter. And there's been a lot of research that says that keeping your brain active is actually a very good way to stave off Alzheimer's. So although the type-safe people don't approve of me making the statement, Scala prevents Alzheimer's. Advanced Scala syntax may cause Alzheimer's, but the point is we don't have to go there. Okay. So I'm going to assume that most of us here have learned a new language. We've learned a new language periodically, and we type in, hello world, we type something into the REPL, and woohoo, hello world, I'm an expert. And what do I do now? And you can sometimes get these, 500,000-page books that walk you through an example, but it's hard to take that and go to your boss and say, I want to start using Scala or Ruby or Haskell or whatever. You need something in the middle. I think of, I became a private pilot, and the first time I soloed, I took off and I landed. And the next time they let me in the plane, they didn't say, go on a cross-country trip with your friends. They said, take off and land again. And then take off and go 10 miles out and come back to the airport and land. And that was a good thing. I got lost, but I made it back. So small advanced beginner steps, step-by-steps, are really a good idea. In part because advanced beginner problems let you work on just a subset of the language. I like to say that if you think of like C and C++ as the feature set being about like this, I'd say we use about this much safely. I mean, out here in the edge, there's the template libraries and all kind of crazy things. Java, maybe, this is the feature set and this is what we use. We use most of it. I think of Scala as bigger, and we have no idea yet what the best practices are for the parts to use. But I'm here to tell you, you can productively use this little bit that isn't scary, and it can give you a lot of power. So advanced beginner projects are good. So my open source music project was built upon a base of my friend Dave Coley's open source project called JFugue. Some of you may be familiar with it. He's given about 4 talks here in past years. Basically, the problem that he set out to solve was if you do MIDI programming, it's horrible. You have to write like 60 lines of code to write a single note. And Dave didn't like to do that. So he wrote a system that lets you basically just say, plays C, D, E, F, and you run this and you get D, 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 D. So it's a very simple, wonderful, concise project. And he got a lot of traction out of that, so being a smart guy, I decided to ride on his coattails. So he had JFugue. I decided to analyze log files, so my project was log4j fugue. So the idea here is a lot of us work on big applications, enterprise scale applications, and a lot of them get to the point that we don't know what they're doing. They're large, they're distributed, they're written by lots of different people. Even knowing what your own program is doing, especially in the middle of the night, can be challenging. When I was working at Motorola, I was doing video on demand. So when do people watch movies? Nights and weekends. So when did I get the support call? Nights and weekends. Our project team was relatively undisciplined about writing log files. So we'd be writing, 100,000 lines of log, an hour, okay? And since it's a running system, doing movies, for Comcast, say you can't just slap a debugger on Comcast, we had to do log file analysis. And that got to be very, very challenging. And I didn't want to have to be looking at the log files. So what log4j does is it takes your log files and it turns it into music, okay? What? The idea is that just like your auto mechanic can listen to your car and hear what's going on, you can actually listen to your application and hear what's going on. And if the demo gods are kind to me, like I said, if the demo gods, where did it go? Okay, there we go. Okay, this is my rendition of Comcast New York Saturday night video on demand. And what I'll say for a minute is, what the system does is it looks for verbs in your log file, verbs like someone ordered a movie. Every time we see an order a movie string in the log file, we increment a counter for bass drum. Every time we see someone finished a movie, we increment a counter for snare drum. When it fails, we get the cymbals. And so you can hear the pace. Something different happened. Something different happened there, too. Something very different happened. Oh, that's bad. That's okay. So the idea is that you can hear what's going on. As over time, you can hear pace differences, you can hear unusual events. You can attend to that in the background while you're doing something else. So you can decide whether I'm really just being silly or not, but it was an interesting application. And it's interesting enough that 2010 I got a Duke's Choice Award for it. And you're a few of the remaining people on Earth that I haven't mentioned that to. So, so that's log4j fugue in Java. Okay, and so basically we associate verbs. We basically look at your application as nouns and verbs. We associate verbs with musical counts. And we do it tempo-based. So if you get two of an event per second, that's 2 half notes. If you get 4 of the events per second, it's 4 quarter notes, and so on and so on. Okay, so that's why we get the rhythm-based system. Okay, this is the architecture for the existing Java-based implementation. So on the left, we have the message listener. It gets the listener from a variety of places. This can work listening to or processing an existing log file or a live stream. It sends it to the message scanner that looks for these interesting verb strings, and then it sends that to the instrument counts. Basically, MIDI allows you to have 16 channels, so we have an array of 16 for each one of those verbs, and we're just incrementing a counter. And then once a second, we switch. This is actually a 2-dimensional array. We switch and we say, play the strings that I counted up in the last second and start accumulating the next second. And then we send it off to this pattern builder that figures out how to turn it into something that JFugue can understand. So that's basically the gist of it. Okay. The main point being that the core of the system is everybody modifying this central data structure. And we'll get back to that word, modifying the central data structure. If you've listened to any of Brian Getz's talks, or you've read his book or Venkat's book on concurrency, shared mutable state, that's exactly what this is. So I don't do multi-threading in this case, but if I did, it would be very difficult because I've got a lot of people sharing a state that's being mutated. Okay. In the Scala version, I took a similar but somewhat different approach in that I have this central message processor that's an actor that basically listens to messages. Now, you may have heard of Akka, which is Scala's message processing library, but there's also a default and simpler message processing library just built in called actors. And I really wanted to use Akka because I wanted to be able to say on my resume that I'd used Akka. And I could not find a need. The simple default actor was sufficient. Damn them. And so the data getter gets data and it sends a message to the message processor that does the increment. And then periodically the sound builder sends a message to the message processor asking for the data. So the idea here that you can already see is we're not mutating shared state, we're sending requests to the message processor to change its view of the state. He's the only one that has the view, and then occasionally he gives a copy of it off to the sound builder. And again, we can get data from an existing file. We can get it from a socket, talking to a live log4j. And then just for kicks, I decided, well, why can't I get it from Mongo? You see how functional programming and NoSQL and resumes all go together? I've done Mongo. The idea is that Mongo, with its schemaless approach, actually there are a number of people who are writing log files to Mongo because it's a high write capable system. And as long as you have a column someplace that equates to message, and a column someplace that equates to when the message came in, a timestamp, you can actually trivially use the Mongo API to get the data. I mean, it turned out to be about 10 lines of code to interface with Mongo. It's actually very cool. And on the other side, we have a simple sound builder that lets us build very simple types of music. But then we went ahead and went to the rhythm sound builder that gave us those really hip-hop kind of music that you heard earlier. Okay, so now is the world's smallest Scala primer. And I'm going to preface this by quoting Obi-Wan, who said, you know, everything we know depends on your perspective. And so if you're a Scala expert, you may find this simplistic, but from our point of view, it's sufficient. So on the left, we see a typical Java class that has a method, and there's a fair bit of boilerplate there. Scala, you can pass a parameter to a class definition, and these two essentially generate just about the same bytecode. The Scala says, oh, I have a foo, and it has an x, and I can get and set it, and so be it. The second line is probably the most interesting one in terms of learning to read some of the code we're going to see, in that, you know, we say, I have a public class, it returns a type, it takes a parameter, and there's a return. Now, Scala tries to infer the type as much as possible. So I actually don't have to, in the second case, I don't have to say float and I don't have to say int. And because I don't have to say them, Scala makes you say them last. So instead of saying float my method, in Scala it's def my method float. And I don't even need to say that if I don't want to. Sometimes, this is actually a segue. A lot of times in Scala, you can omit things because you know the compiler is going to supply it for you. There are times when it's a very good idea to leave it there, both because someone else can read it and they can figure it out, and just in case you got it wrong. I mean, in this case, it's pretty clear that we're returning a float. But when Scala gets a little complex, you can say, oh, I know it's a returning of this, and you put that type in the return type, and Scala says, you're not returning that at all. So it's not a bad idea to put things in, even though the compiler can infer them. Let's see. On the third line, Java, of course, methods have parameter lists. Scala methods can have multiple parameter lists, which sounds kind of weird, and it can be kind of weird. And again, it's an area just to be a little careful of. But if anyone ever heard of currying? Okay, currying, right. So with multiple parameter lists, you can say, here's a function, I've got multiple parameter lists, I'm going to bind some of the parameters, and then I'm going to call this curried function that on the second set of parameters. It's kind of an advanced topic. The place that I'm using it here is for dependency injection, and we'll get to that in just a minute. I don't want to talk about closures. Although I will say in all the talks the last couple of days where they've said, closures are in Java 8 and everyone's already moved to Java 7, so it's all good. And then I talked to people around me, I said, you guys moved to Java 7? It's like, no. You know, you guys moved to Java 6? It's been scary how many people have, I mean, I actually heard someone here saying that they're still on 1.4, which is, so go Java 8. I'm sure one day most of us will have access to it in our companies, but I don't think that's today. And so the last one is a dependency injection. I'm a big Spring fan. You do dependency injection through Spring, and life is good. In the Scala world, it's still kind of early days, and we're still figuring out what are the best practices. There are a lot of different ways to do dependency injection. Since I learned Scala from Dick Wall, and since he has a dependency injection framework of his own called Subcut, I use Subcut. And Subcut uses a kind of scary Scala feature called implicits. So in Java, if you've got a function and you use a variable that doesn't exist, The compiler says it doesn't exist. Compiler error. Scala says, well, I don't see it here. Do I see it anyplace else? And what you can, it looks around. And so it tries to help. One of the things that Dick Wall says is when he programs in Java, he feels like he's working for the compiler. And when he's programming in Scala, he feels like the compiler is working for him. So you can say, I have a variable. And maybe that variable, oh, I don't know, is my configuration. And I'm going to mark it as implicit. Now I have, in the same scope, a method that uses something out of configuration that you never mentioned before. Scala says, yeah, that'll do. And it implicitly uses the thing, okay? So it can be overused. I have a term for this that I'm trying to get people to adopt called invisible spaghetti. So you look at a line of code and you're perhaps not sure what it does, but implicits used cautiously can be very powerful. I mean, why should I pollute my whole call stack by passing my configuration all through when I can just say, here's my configuration, just use it. Just figure it out. So that's what that is. Okay, let's look at some code. Now let's... Yeah. Besides switching jobs recently, I also switched from the PC to the Mac, so I'm just still learning the oneness of Mac. Steve. So the first place to look is where do we store, in the Java version, where do we store the information about the association between the verbs that we want to look for and the instruments that we want to play? Well, it's in, I called it instrument voice. And basically it has here a voice number, which can be 0 through 15 because you have your 16 MIDI channels. It has the search string that you want to look for, and it has the instrument name, bass, drum, piano, whatever. Okay, so, and then we have some constructors, then we have some accessors, then we have some more accessors, we have some setters, some mutators. So it's 102 lines to not do a lot, okay? So, but that's cool, it's no big deal. If we go to the Scala version, it's that line. Is it easier if I don't highlight it? Yeah. It's that line. That line is equivalent to the 106 lines of Java code. A case class says, I'm one of these things, you're going to have a bunch of them, I want to be able to switch on them later. And it has essentially the same thing. It has the message I'm looking for, the string, and then the MIDI voice. So on my first day of coding, I said 106 lines to one. Shazam! It's doing okay. I rock. That's what I said. Let's go back. Okay, so that's the instrument voice. So now let's see what we do with it. So we have this message receiver class. Going back to the Java code. Okay. And so, of course, I have to do a whole bunch of setup. I get my map of those instrument voices. I set up another map. I set a whole bunch of variables. I set a constructor. I set where I'm going to read the data from. I set the music object, which is something I'm going to play later. I have to loop through the messages and set them. I have to initialize another message map, and I loop over them, and I set them so I can easily parse them. I have this guy, swap counters, which should scare the heck out of you because it's like, okay, I notice later that it's not synchronized. I'm just randomly switching the counters out from under things. But I figured, it's music, what could go wrong? And then eventually I process the message. Now processing the message, this is sort of the guts of it. So I get a message in, just some random log message. I get myself an iterator over my messages. I walk through the iterator, I get the key, I get the pattern, I search for it. If I find it, I increment the key. Okay, nothing terrible. I mean, this code is not going to win any awards, but it's also, it would pass most code inspections. I mean, it's, you know, it's kind of boring. So let's go to the Scala equivalent. So here I have message processor, and it extends actor. And here's this auto-injectable thing, okay? This basically says, hey, if you see anything you don't recognize, it's okay. You'll find it someplace. So we inject the messages, and we just inject them from implicit space, basically. We have our set of the counters. And basically here, this line right here is the equivalent of all of this, okay? So what we do, let me just see the, okay. Basically, anytime this actor receives a message, we come down here and we try to switch on it. And ignore these two cases for the moment. And let's just say we got a string. Well, what do? Okay. We say, hey, for all of our messages, and remember up here we got the messages, that's the possible messages. For all of the possible message, if the message contains this message, then increment the counter for that voice. That's it. That's all the processing. Whereas in the Java version, sorry. Oh, come on, Mac. Yeah. In the Java version, I told it explicitly step by step how to do it. In the Scala version, I more or less said what I wanted to do. I mean, if you think about what do you want to do? You just want to say, well, for all the messages, if this is one of the messages I want, increment. Well, that's essentially what it does. Now, you notice that I've got a commented out line right above. This is sort of the yin and yang of Scala, in that Scala always has multiple ways of doing things, and we're still figuring out what the best ways are. So another idiom for all of this is to say, hey, messages, filter, and then we pass, this is essentially a closure right here. Message contains log message. And then for each one of those, do this other closure, current second increment. But go away. Thank you, system, for helping me. Hey, demo gods, outstanding. Oh, come on, be nice. Okay, there we go. So there's basically two ways of doing that, and there are people who passionately believe that this way is right, and that anyone who believes the otherwise is clearly an idiot. And there are just as many people who go the other way. So after presenting this a few times, I put them both in and commented one out, and you can decide which is which. But the idea is that you've got one line of code that kind of reads like, if you were writing the pseudocode, it's like, well, take all the messages, filter them, see if it matches, increment. At a certain level, I think that's just a lot simpler than this. So anyway, so we get the messages. Now let's look at building up, let's look at getting the data, let's say. Okay, so here is our simple data getter. We're going back to the Java version. And I extend a thread, because this is basically you have to have a thread to get the data, and then a thread to play the data. So I have my setters, I have my getters. Clearly, I was a little optimistic or pessimistic there. I probably should take that out. We'll pretend I did. I never showed that. You didn't see anything. And then in this simple case, basically, I wanted just to see, am I getting anywhere when I was first writing it? So I said, I'm just going to have an array of messages. So just walk through the array, write them and see what happens. Okay. Again, 88 lines of code, no big deal. The IDE will generate a lot of that for you. But it's still, it's still 88 lines of code. So let's go to the simple data getter in Scala. Well, it's essentially 2 lines of code. It's basically, take my sample data, which I've injected, and iterate through it, and then this bang symbol is send. So basically, send the message to the message processor. So again, I'm not saying that the 88 lines of code in the Java version is so hard to write or hard to read or anything, but 1 line of code which just says message processor bang message, I think is simpler. Okay. So now let's look at the side where we're actually processing the data. Okay. Okay. So we're going to look at Sound Builder. Sound Builder. Okay. Okay. So we're back here in Java land. Okay. And again, I've got a variety of variables that I've set. I've got my player, I've got a synthesizer, I've got a bunch of setters and getters. And part of the trick is none of this is hard. And like I said, the IDE will generate it for you. But then when you're running it, you have to go find the interesting bit of code. Where in all of this IDE generated code are the good bits? Okay. So here's some good bits. Okay. So we've got the run method for the Java music processor. Okay, so the first thing we do is we swap the index, because now we're ready to play. We want to say I want to look at the ones that I've just generated and switch them. Okay, I build my music string right here. We'll go into that in a sec, and then I play it. And so at a certain level, that's pretty cool. That's pretty simple. Okay, build a music string. Okay, basically I walk through all of my MIDI voices 0 to 15. I get the voice. If there is a voice, I explicitly pull out the pieces, and then I build a voice string. So again, this is trivial code to understand, but it's very imperative. This is how you do it. Okay, and then we can come down here, and build a voice string is not all that terribly interesting. I mean, here's where we get into some of the guts of JFugue's particulars, and all of this code's online. Okay, so let's go back to the Scala version, Sound Builder. Okay, Sound Builder. Okay. Now, one thing you'll notice in here is there's no run method. So how does this work? And you'll notice that we have with auto-injectable, but also with Sound Builder. So let's go look at Sound Builder. Sound Builder is a trait. Trait is new to us. A trait is an interface with the default implementation. Now, they've said that Java 8 is going to have that. Was it Java 8 or Java 8.4, Java? I mean, I don't know. Some Java will have that. But I mean, because and I'm glad to see Java getting it, because we used to have you'd have the standard paradigm of you'd have your interface, and then you'd have your abstract base class that would have the things that your default implementation. Then you'd extend that, and you've got three artifacts. Why do I want to have 3 artifacts? Just so I can have a default implementation. So my Sound Builder basically accepts all these implicit parameters, and then he's got his run method, and he says, while I'm running, build and play the music string. Okay, now this line again is equivalent to that, and I think it's simpler. I mean, again, what it says is, hey, message processor, I'm going to send you a message called next data, and when I say bang, it's an asynchronous send. When I say bang question mark, it means I'm sending this to you, you give me something back. Okay? So, hey message processor, please give me some next data, and then pass the data off to the music player. Okay, let's see how that works. Message processor. So now we come back to the main body of the Scala code, which is this one loop statement, essentially. So, this line of code, line 47, is the one that did the increments, and this line of code, 43, is the one that sends the data over. So he says, current second, and clone a copy of the data. So it's important that I'm cloning it, so no one else is touching it. I'm not sharing mutable state. I'm making a copy for someone else to touch. And then I zero out the data, and then I can keep going. So I've got one line for getting the data, 2 lines for processing the data, and then a line of code to exit. I mean, that's the guts of it. So I think that's pretty cool. Again, this isn't hard, but this is an imperative style. This is saying what to do this is saying how to do it as opposed to what to do it. So this is the simple sound builder. So let's go look at the rhythm sound builder, because that's where it gets really scary. And this is where I have to say, I wrote this. It's a little funky. So again, I have my run method, and basically, when I'm doing rhythm instruments in JFugue, I have to say I'm basically constructing a string, and the string will be dot, 1, 2, little o, big O. Basically, for each one of those, for each musical instrument, I have to say a letter that's going to represent that instrument. So I have this rhythm substitution down here. Yep, rhythm substitution, where basically I walk over all the instrument names, I turn them into a string, and then I put this instrument name inside the bracket so that JFugue can play it. And then I have to remember a rest. If anyone here is a musician, the space between the notes is also note. It's very interesting, negative space, all that cool stuff. And then we have a bass drum, which is the underbar, so you always have a beat. Okay. Okay. Now, sort of the scary part is, so now we're going to walk through all the layers. Okay. We're going to get the voice. Then we're going to get the play count. Then we're going to decide, should I be playing this layer or not? Because one of the tricks with JFugue is if you start playing, if you play a measure and it has a bass drum, and then you play the next measure and you don't say anything, the bass drum keeps playing, which is kind of cool, kind of bad. And so I had to have all this logic and just look at play this layer, how many times it's highlighted, to tell whether in the last iteration I had used this instrument, so I needed to clear it on the next one, or I needed to set it. I mean, I look at this code and I'm like, oh, this code is getting pretty ugly. So I didn't really love that. So maybe it's a good thing I rewrote it in Scala anyway. Let's see, the Scala version. Okay. Again, build rhythm. I tried to keep the names as similar as possible. And again, I used closures. I said message filter, and what am I filtering on? Well, I'm filtering on everybody who had a count. There's no sense in playing anything that doesn't have a count. Then build a layer string, set the layer, and play it. Now, one of the things that's kind of interesting here is this is an example of someplace where I didn't need to specify the return type. So I'm building, so right here I'm saying the return type of this guy is a rhythm. And that's how you do a return. In Scala, the last statement in a method is the return value. Okay? So I actually could take this off, but my own style rules sort of say don't. Because suppose I put something after this line. If I left this off, I mean, so one of the tricks that actually has bitten us is suppose I come down here and I put log info blah. Okay, this will fail to compile because the return value of log info is a string. Okay, and it will actually give me an error here saying you're no longer returning a rhythm. But if I had taken this out, it would say, okay, I'll you want to do that, so be it. And hopefully it would blow up someplace else. But it might not, because somebody might have defined a converter from string to rhythm, because rhythm really is, at a certain level, just a string. So I'm a firm believer in explicitly saying what the types are. Now, build the layer string. Again, you'll notice all these vowels. Vowels are essentially finals, okay? So when I build a rhythm string, I said, okay, I've got a silent note, I've got 16 beats to measure, how many beats do I have in between notes? Because if I've got, if I'm trying to do 4, if I've got a count of 4, then I've got 4 beats in between. If I've got a count of 2, that's 16 divided by 2, I've got, 8. And so I essentially only have one loop. I've said right here, this is actually kind of an interesting method. I say, make me a string using string builder. And what should I do? I should do silent note, which is the dot right here, the rest, times beats per measure. Okay? So I've essentially put in one line, all of the places where there are going to be rest notes, and then I just have to put in, with this one loop, all the notes that aren't rest. Okay? So again, you compare that with build rhythm string, build layer string. Here I took the imperative thing of saying, okay, I'm going to have 16 beats per measure. I'm going to have this many notes between the beat. Walk through from 0 to 16. If the count is this, put in a silent note, otherwise put in the other thing, and reset the counter of how many beats it's been since the last beat. And it's like, this code is easy to get wrong. Okay? Maybe I should be better, maybe I shouldn't be easy to get wrong, but it is easy to get wrong. This code is a lot simpler. So where do we go next? So we can walk through some more, but that's basically the gist of it. I want to just give you a sense of what you can do, with Scala and with Java. And you notice, I didn't do a lot of the scary things that you can do with Scala. I used basically just closures. I used vals instead of vars. Vals mean essentially a final variable. Var means something you can modify. And it became very straightforward. Okay? So let's actually switch back. Let's switch back the other way. Okay. Whoops. Oh, come on. Okay. So basically the gist of this is, by using a very small subset of Scala, you can get incredible efficiencies, similar to, but I think better than the efficiencies you can get from Java 8. We didn't really touch on it in this case because it wasn't multi-threaded. But because I was using essentially final variables, if I needed to make this multi-threaded, I wouldn't have to put synchronization primitives on it. Because since everything is a val, I don't have shared mutable state. So I could multi-thread this trivially without having to worry about collisions. So one of the other things is that a lot of us won't be able to just switch to Scala because of business environments. But what we found is using Scala helps you adopt this functional mindset. And so, right now in my current job, I'm actually not using Scala, we're using Java. But my boss and I, who are the two coders, we both are very familiar with Scala. And so we're writing Java in a more functional way. We're trying to write what we want it to do as opposed to how. So this goes back to the notion of just learning a new language gives you basically a leg up. And functional programming is something that's turning out to be very interesting. So whether you encounter it now with Scala or eventually with Java 8 with closures, it probably will be in your future. So that's it. So any questions? Okay, yep.
First of all, I love your application.
Oh, thank you.
Do you have the code samples you've written available for us?
Oh, sure. It's, sorry, that was the, yeah, okay, this is a little hard to read, but it's on, the Java version is on www.log4jfugue.org, and the Scala version is at GitHub. So these slides will all be available. And I'd love contributors. I mean, there's some interesting things that we want to do. I mean, one of the things is, as I said, if you get 2 instances of a thing, you get 2 whole notes. If you get 16, you get 16 16th notes. One of the things I've wanted to play with is, well, what if I'm in an environment where I'm getting hundreds of events per second? It would be great if I could implement some kind of logarithmic scaling to pull the counts down, and I just haven't done that. Another interesting area is we're wanting to try to do chromatic music as opposed to just beats. But that's those are future examples. You also have the ability, I didn't get a chance to show it to you, but you also have the ability to replay a log file at different speeds. So.
Yeah, the idea of using music for data visualization or whatever. Are there other applications you've looked at for that?
Yes, actually, there was this very, very interesting one in Boston that I heard on NPR, in that emergency rooms apparently have, I've always been unconscious when I've been in there, but emergency rooms, or operating rooms rather, have lots of medical instruments, and there are apparently more medical instruments than the doctors and nurses can attend to. So they came up with this very cool system, and I've written to them, but I haven't gotten an answer back, where they will play an orchestral music piece, dun 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 da da dun, and they will tie the medical instruments to the musical instruments. So if your patient's blood pressure is crashing, dun 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 dun, and so people notice that. Now, I think this could get a little extreme, and if your patient is having a really bad time, dun dun dun, dun, you don't want your music to be freaking out on you. But the idea of everyone is very interested in application visualization, but vision is our primary sense. We don't pay a lot of attention to our other senses. Since we have a moment, I'll just do a segue. In a previous lifetime, I used to be a dolphin trainer, and so their primary sense is acoustic. So I got very interested in acoustic tasks, and all the research says the multitasking is bad, but if you multitask across different modalities, you actually can get away with it a little bit more. And while the music that we were playing, it's not gonna, where did it go? It's not gonna win any awards necessarily, except for Duke's Choice. It's not gonna win any awards, but you can listen to this in the background, and you can be doing other things, but you can still notice when something happened. So if you're a system administrator or system monitor, you can do your regular task and have these things going on in the background and still pay attention. And you could be doing other tasks, you could be playing games, whatever. So, I mean, the whole notion of using our other senses, I mean, we also talk about code smells. I haven't figured out, log for smell. Smelly log. But there should be things there. I mean, we get the system vibrates. There's no vibrate sensor in our Macs, but I think it's an interesting area. If we're going to handle multitasking and all that, I think it's going to be there's room for exploration there. So, other questions? Okay. Oh, go ahead.
How's the performance compared to Java and Scala?
It's totally fine. I couldn't tell a difference. Yeah, I mean Scala compiles down to bytecode. So it's just bytecode. So.
How do you debug your Scala program? Does it drive you crazy and you have to debug?
Not really, because I haven't done anything insane. I mean, at least in this context, you know.
You might want to step into something or step out of something.
Well, you can. I mean, it's you just. I mean, it's funny. One of the things about Scala is that some of the really top Scala people say, "Oh, I don't need an IDE. I'll just do it in VI." And back in Boston, we have some really amazing Scala folks. And there's this one guy, Runar. I went from 2,500 lines to 250 lines. I'm sure Runar could write this application in 3 lines, but none of us would understand it. So don't do that. I'll take 10 to 1. You know, I don't need 100 to 1. So you can. I mean, let me go back to it. I mean, you can. This is Scala, yeah. I mean, here, you know, step. You know, step over this. I mean, the IntelliJ support for Scala is really quite nice, and things are only going to get better. So right now, if you're using some of these implicits and you hover over something that has an implicit, I don't believe it automatically tells you, oh, by the way, there's an implicit here, but that's coming. Okay, so I haven't found it to be a problem, in part because it's simple. You know, when there are 250 lines, there are 250 places my bug could be. You know, more or less. There was another question?
No, I was just going to add for Eclipse tool support is getting better all the time. So now you have the cover, the value inside the Eclipse.
Absolutely. All of the IDs are getting better. Just for my own sake, I keep I keep Eclipse, Java over in this brain, and Scala, IntelliJ in this brain, but they're all fine. So yeah, the tooling's fine. The compilers are great. Anything else? Okay.
How long time did it take you to convert the program?
It was 10 days. And so the funny thing is, I did this over the Christmas holidays, and I came back to work, and people said, "Oh, what did you do for fun over the holidays?" And I said, "I learned a new computer language, and I rewrote my open source project in the new language." And they said, "What did you do for fun?" And I said, "I just told you what I did for fun. I'm a geek." You know, / I'm going to have a job next year. So yeah, I mean, here's the thing. This again is the message. You can spend your life doing, Scala and learning all these things, but I took a course and then I took, 10 days and rewrote the thing, and it worked. This is the cool thing. So I have my unit test, and when I finished writing it and it passed all my unit tests, I went home, I went downstairs and I told my wife, "Hoo-hoo, I'm done." And she said, "What did it sound like?" And I said, "Oh, it never occurred to me to actually run it." It passed my unit test. I figured I was done. And so I went upstairs and played it, and it ran. It ran the first time. So go unit testing and go Scala. So, yes? All right, thanks very much.